Lesson: Data Anonymization and Minimization. Data anonymization and minimization are critical components of data privacy and protection, particularly in the context of artificial intelligence, where vast amounts of data are processed and analyzed. These practices are essential for ensuring compliance with privacy laws, safeguarding user data, and maintaining trust in AI systems. Data anonymization involves transforming personal data in such a way that individuals cannot be identified, while data minimization refers to the practice of limiting data collection to what is directly relevant and necessary for a specific purpose. The implementation of data anonymization involves several techniques, each with its own strengths and weaknesses. An effective approach is the use of pseudonymization, where identifiable information is replaced with artificial identifiers or pseudonyms. This method retains data utility while reducing privacy risks. For instance, in a healthcare setting, pseudonymization allows researchers to analyze patient data without exposing personal identifiers, thereby maintaining patient confidentiality. Another technique is data masking, which involves obscuring specific data elements within a dataset. This is particularly useful in testing environments where real data is replaced with fake data, ensuring that sensitive information is not exposed during software development. Generalization and suppression are additional anonymization techniques used to protect privacy. Generalization involves reducing the granularity of data, such as reporting age ranges instead of specific ages. Suppression entails removing entire records or data fields that are deemed sensitive. The K-anonymity model combines both techniques to ensure that data cannot be traced back to an individual. Under K-anonymity, each record is indistinguishable from at least K-1 other records concerning certain identifying attributes. This model has been successfully applied in various domains, including demographic data and transaction logs. Data minimization, on the other hand, requires a strategic approach to data collection and storage. Organizations are encouraged to adopt a privacy-by-design philosophy, integrating privacy considerations into the development of projects from the outset. This involves conducting privacy impact assessments to determine the necessity and proportionality of data collection. By prioritizing data minimization, companies not only comply with regulations like the General Data Protection Regulation, but also reduce risks associated with data breaches and misuse. One practical framework for implementing data anonymization and minimization is the Data Privacy Framework. The DPF provides guidelines for aligning data practices with privacy principles, emphasizing transparency, accountability, and user control. Within this framework, organizations can employ tools such as the Data Anonymization tool, which automates the anonymization process by applying various techniques to datasets. This tool not only streamlines the anonymization process, but also ensures consistency and compliance with privacy standards. Real-world case studies demonstrate the effectiveness of anonymization and minimization strategies. The Netflix Prize dataset, for example, serves as a cautionary tale of the risks associated with insufficient anonymization. In 2006, Netflix released an anonymized dataset for a competition to improve its recommendation algorithm. However, researchers were able to re-identify individuals by cross-referencing the dataset with external information from the Internet Movie Database. This incident underscores the importance of rigorous anonymization practices and the potential consequences of neglecting them. Furthermore, organizations can leverage privacy-enhancing technologies to bolster their data protection efforts. Differential privacy is a robust PT that provides mathematical guarantees against re-identification. By adding controlled noise to datasets, differential privacy ensures that the output of data analyses does not compromise individual privacy. This technology has been adopted by major tech companies like Apple and Google to enhance the privacy of user data while maintaining the utility of their analytical models. The integration of data anonymization and minimization into AI systems also requires a cultural shift within organizations. Data governance frameworks should be established to promote ethical data handling practices and ensure accountability. Training programs can further equip employees with the necessary skills to implement and uphold these practices. By fostering a culture of privacy, organizations can align their operations with ethical standards and build trust with stakeholders. While data anonymization and minimization are vital for protecting privacy, they also present challenges. Balancing data utility and privacy is a persistent issue, as excessive anonymization can render data useless for analysis. Thus, organizations must carefully evaluate their data needs and select appropriate techniques that preserve the value of the data while safeguarding privacy. Additionally, the evolving nature of technology and the increasing sophistication of re-identification methods necessitate continuous monitoring and adaptation of anonymization strategies. In conclusion, data anonymization and minimization are indispensable practices in the realm of AI ethics and governance. By employing techniques such as pseudonymization, data masking, and differential privacy, organizations can protect user privacy while maintaining data utility. Frameworks like the Data Privacy Framework offer actionable guidelines for implementing these practices effectively. Real-world examples and case studies illustrate the potential risks and rewards of anonymization and minimization, highlighting the need for vigilance and adaptation in a dynamic technological landscape. Through a commitment to ethical data practices and a culture of privacy, organizations can navigate the complexities of AI data protection and uphold the trust of their stakeholders.